one of the products that's got a lot of attention to your one lock system. So I want to start diving into that a bit. Can you describe in layman's terms what that system is and how it works and what problem it was aiming to solve for foilers?
Mm-hmm. So overall, it's a system that simplifies everything, right? We had Phantasm before, which was a foil platform with a fuselage that was aluminum, a front wing, back wing, and a mast, and they all kind of connected together through screws. So we had 3 screws on the front wing, 3 on the mast, and then 2 on the stabilizer, and then 4 up on the pedestal. Right? And we had a lot of issues with corrosion, with breakage, quality control, and weight, and then also this inherent kind of drag that we had underwater. So when you would ride on a wave, you could feel as soon as you let off the power, you'd kind of slow down a little bit. And so we kind of figured, hey, how do we make it easier for the customer, somebody buying our product, to actually enjoy the product? And that's in a couple ways, right? It's the setup, ease of use there. It's the performance on the water, and also just the weight savings that you get with going with a full carbon system. And so we decided to throw out Phantasm basically 3.5 years ago now, I think. It was like right when I started, the first meeting I went into was, hey, we're looking at this new idea. How do we not reinvent the foil, but like reinvent the connection system of a foil to make it as streamlined and easy as possible to use? And so there were a bunch of strings and 3D printed parts that we were playing with. And when you go back and you look at them now, they're so different from what we ended up coming out with. But yeah, we just went down that path. And it was tricky because we were trying to make a system that's super streamlined, but still strong enough, right? We wanted that durability, and that Slingshot's really well known for in our kites and our wings. And so that had to be in the foil as well. And so we basically decided we wanted a system that would work with variances and tolerances in China, right? Because every piece that comes out of mold is slightly different. And so you have all these brands having to kind of fine tune their finishes, or have somebody in the factory down the line sanding it, and you get a lot of variance there. And so we needed a system that could deal with that and to kind of cut down on the amount of labor that went into it. And so we have the system where the pieces basically pull together and expand inside the collar. And you can see the videos online, basically two that fit inside of another triangle. And the tighter it is, the more it expands into it. And so when you get it out of the mold, let's say it sits right here, over time, when the carbon wears, as it does with any system, you see any foil that's been on the market for 3 years now, there's a little bit of slop, right? And the screws kind of take up some of that, but there still can be a little bit of play. Ours, as the carbon wears over time, it just pulls closer and closer together. So it's basically expanding more and more and locking into the system. So it's just as tight 3 years down the line as it was the day you bought it, because it just has that kind of tolerance fit going on in it. But basically, in the end, we were able to simplify everything, avoid that corrosion that we had. We have full carbon. The manufacturing costs went down a little bit too. We didn't have to use such high level carbon with the geometry that we had, because when we had that mast foot that went into the fuselage, you had a limit on how wide the profile could be, right? And with developments of profiles overall through softwares, we've been able to find profiles that are wider but still have less drag than our narrower race profiles that we used to have in the Phantasm series. And so we can get a lot more strength without adding like $1,000 to the first cost or something like that. And so that's helped us kind of differentiate. Now we have 2 mast lines instead of 1 with Phantasm. Keep a lot of strength that's way stronger than Phantasm overall. We don't have the breakage in the mast that we used to have, or the fuselage corroding and snapping over time, or the screws stripping out. And so it really solved all of those quality issues that we had overall. And then on the water, this was kind of like the aha moment, was when we would ride and then go back to Phantasm, you would realize how much drag those screws were actually creating. And it was hard to realize until you'd actually ridden something that was streamlined, right? Like have you ever been on an E-foil and you let out on the throttle and you feel that instinct down a little bit? Yeah. So Phantasm system, we were feeling when we went back to it, not that much, but like 2 to 5% of that same feeling was going on, where when you let out on the power, you would feel that foil start to get a little unstable and start to pull down a little bit, and because of all those screws along the bottom and all the weird seams and stuff with the mast foot and the fuselage and just all the connection system. So by going back to Phantasm, we actually realized the biggest benefit to the system was not actually the ease of use or lack of corrosion, all that stuff. It was the feel on the water, which is pretty exciting to see. So there was that performance benefit that we saw from one lock over the Phantasm system that we had before.
So yeah, it's interesting because I suppose one of the challenges maybe for you guys is everyone thinks it's all about just the ease of not having screws. And you know, the process was getting rid of screws because they're a pain in putting together a foil. But there's a lot more to it than that. And I suppose there's a bit of a job in getting that message out there, because a lot of people are thinking, no screws, it's quicker. But there's much more to it than that.
It's pretty hard to describe a feeling without sounding like a generic water sports company that says like, feel the flight or something, like that doesn't actually speak to anybody. And so in the beginning, we kind of more focused on what we could actually show, which was the ease of putting it together.
Yep.
And then now we have people that have gotten the foil that are talking to their friends, and they don't actually talk about the easy use as much as they do the feel on the water and how smooth it is. But it's really hard to describe that in an Instagram post or an email or on an ad on iWindsurf or iKitesurf. And so it's a bit trickier to describe that to the customer. We're trying overall through the riding that we're showing on the water, and really through demos and stuff like that, is everyone that comes in and demos the foil really enjoys it and notices the lack of screws when they go back to their other foil. So it's kind of like you can't tell somebody, they just have to feel it themselves, which is why our new motto is feel the difference for the new year, is actually like asking people to go try our products, not just the foil, but the kites and the wings and the boards. You do notice that feeling when you get on any one of our products. And that's really what we've tried to do is make it so the customer feels what we want them to, or like the benefits in our product overall, and the ease of use and the smoothness and the efficiency overall.
Certainly people that are racing foils are covering up their screws to make them more streamlined. So I suppose you just don't have that issue with this foil.
Yeah. I mean, it's not a race foil, I will say that.
It's sure.
Made for going as fast as possible. There's a lot of compromises you have to make on both sides, whether you want to go race or kind of generic for the average customer that doesn't need to go 50 kilometers an hour. So there are things that if you wanted to make it full race, you would change. But for the speeds that people are riding at, it's plenty fast overall.
Yeah. And what were the biggest engineering design challenges for you guys in putting that system together?
Strength overall, right? Like you have the carbon weave coming down the mass, and then it has to open up around the open collar at the bottom, so the carbon weaves around. And so in the beginning, we had a certain thickness in the sidewalls of that collar, and my job was basically to break a lot of stuff. That's kind of like go out and ride it and see if you break or if the product breaks first, right? And so I was doing that a lot, and I was breaking a lot of mass, trying different layups. They got stronger and stronger, but we never really hit the point where we were happy with it. And so we actually retooled all of our products, like 3/4 of the way through development. We said, hey, we need a lot more strength in here. So we beefed up the amount of material on the collar by going closer in, not expanding on the outside, because we know we wanted low drag. We don't want to have it be a bulbous piece, but the inner part of the collar got material here. And so we retooled our front wings and our stabilizers to be a little bit smaller to have that strength where it needed to be in the collar. That was a big piece. We had obviously QC issues, factories changing things on us last minute a little bit, just trying to make the process of building easier. And so we had to remind them of like the durability standards that we needed. Sanding overall, teaching them how to sand the foils to be smooth through the water, that more gloss isn't necessarily better, things like that. And then obviously we have these flag screws on the top. We call them T-locks that they're kind of like the Conrad things, but they lift up and you can set them into position like you want, trying to find the right aluminum for that so they don't corrode. New T-nuts that for M6, we switched to that from M8 to try to save on weight overall, and just easy use and tunability for this RTS system that we have. It allows you to notch the foil plate into the board and then smack the back down and then put T-locks or flag screws in the back. We needed to change to M6 for that too, so we could have these little sleds go on the bottom of the plate. So yeah, I would say strength was like the main challenge, and then also the latch actually has a lot of thought behind it. We wanted to make sure that when somebody gets a completely new way to assemble their foil, generally they're going to over tighten it, right? So the latch, they're going to be like, oh, I don't trust it to slam it down, right? We wanted to make sure that we like tried aluminum latches and hard density plastics and soft density plastics. We want to make sure that if people were to over tighten that latch, they wouldn't end up breaking the fuselage, because you've got a little notch in here that the latch goes into and then tightens down. And as it tightens down, it pulls against the little surface here. If it was metal and somebody tried to do that wanted to tighten it down where the tension starts here and they locked down, it would crush the carbon right here. And so we kind of spent a long time figuring out what's the right density of plastic in our latch so that it stays very strong and keeps its shape unless you were to over tighten it. And we wanted to make sure that the latch crushes before the carbon, because the latch is like, it's like $4 to replace and the stabilizer is $300. So it's like which if you're not assembling it correctly. And then so in the latch you can adjust it. So there's a little pin with the Dyneema line. And over time, as that foil pulls closer together, right, you need to have adjustability so it still stays tight with the latch. And so there's this little pin that you unscrew. And it was like, what's the size of that pin need to be? How much stiffness does there need to be in that pin? How does it back out without hitting the sides of the fuselage? So the latch was really took a lot of time. The latch and then the strength of the collar we spent the majority of time on overall.